A survey of 15 large U.S. cities finds that the average commute time one way is 25.4 minutes. A Chamber of Commerce executive feels that the commute in this city is less and wants to publicize this. He randomly selects 25 commuters and finds an average of 22.1 minutes with a standard deviation of 5.3. At a 1% significance, is he correct? We know this is a t-distribution or a t-test because we have a small sample and the standard deviation comes from the sample. Let's set up our null and our alternative. We know the null is going to be mu equals. In this case, the time is 25.4. The question always is, what's my alternative? Well, in this case, we're talking about less. So my mu is going to be less than 24.5. This is a one-sided test because we're talking about a less than symbol. So we're talking about 1% significance. So the area to the far left, my rejection area, is going to be 0.01. This is going to be based on degrees of freedom of 24 because I have an n value of 25, 25 minus 1. So now I need to go to my t-distribution chart. I go to my t-chart. I find the critical value to be negative 2.49. So anything below 2.49 is going to fall into this rejection region. Well, next I find my test statistic. Do everything we've done before. And I'm going to find a test statistic of negative 3.11. Since this test statistic is below negative 2.49, it falls in my rejection region, which means I'm going to reject the null hypothesis, which means that this information, the data provided from these 25 commuters, does support the executive's thought that the city is actually less than the 25.4 minutes, that his city actually travels less on the average commute. It does support that idea.